All right, one of the big things we did in geometry, some of you guys had me in geometry, some did not, but we talked about congruent triangles quite a bit. Do you remember talking about that? Yes? No? Yeah, that's got to be something. I mean, I know it was a couple years ago, but still, congruent triangles should be seared in your brain. All right, congruent. We have a symbol for congruent. Do you remember what that symbol is? Yeah, it's an equal sign with one little squiggle on top of it, okay? Now, we did not, in your class, we did not get to similar triangles when I taught you geometry. So if you had me, we did not do similar triangles. I don't think we did. I usually do, maybe my honors classes we get to similar triangles, but anyway, the symbol for similar triangles is just the one squiggle. All right, so congruent, you got an equal sign under it and a squiggle. Similar is just the squiggle. I don't know if there's like an official name for that or not. It's just the symbol that we use for similar triangles, okay? Do you remember what the symbol for a triangle is? Take a wild guess what it looks like. A triangle, very good. All right, and how do we name a triangle? So if I had a triangle like this, and I called that point A, point B, and point C, how would I name that triangle? Triangle what? ABC. Good. Or, is that the only thing I could call it? Do I have to go in order, in alphabetical order? No. I could, if I wanted to, could call it what? Triangle CAB? What's another thing I could call it? Triangle CBA? I could do that, start with that A again and call it what? Instead of ABC, I could call it what? ACB, right? A whole bunch. I think there's 6 different ways I could name this. And then I could start with what? The B, right? I could call it triangle BAC, or I could call it triangle BCA. All right? All kinds of different names that you could call that particular triangle. All right? Remember all that stuff? What does it mean to be congruent to each other? So if I had a triangle, okay, so there's my triangle. I'll group it and copy and paste it. Now, I copied and pasted it. What does that mean? Whoops. Tell me something about that second triangle compared to the first triangle. Well, they're not equal to. What's the word? They're congruent. Watch. I could take this triangle and put it right on top of it, and it fits perfectly. Do you see that? All right, if it fits perfectly, that means that the triangles are what? Congruent. All right. So we'll use that ABC again, and we'll call this ABC, DEF. Okay? Now, if these are congruent to each other, equal sign with a squiggle, if they're congruent to each other, what do you think is equal? Like angle A.
The angles.
Well, what angles? Like all the angles are equal to each other? What do you mean, just the angles?
They would add up to be
No, it has nothing to do with congruent triangles.
angle A is equal to angle.
Thank you. Angle A is equal to angle what? D. So if this has an arc, then this has one arc. See that? One arc, one arc. That means that they are equal to each other. Or sometimes we say that the angles are also congruent to each other. It kind of means that they're equal. All right? How would I differentiate between angle B and angle A? If angle A has one arc, what are we going to do with angle B? Put 2 arcs. Remember this from geometry? Is it coming back to you at all? Yeah, we did this so many times. You got to remember this. So angle B equals what over here? Angle E, right? Because when I took that triangle, put it right on top of it, right? And I just moved it over. I didn't twist it. I didn't flip it. I didn't do anything to it. All right? So you know that all those, we call them corresponding parts, okay? All those parts right there that match up with each other are equal. Now, if that has 1 arc, that has 2 arc, what am I going to do with C? Put 3, all right? So what's angle C equal to over here? Angle F. So I'll put 3 right there. So if these triangles are congruent to each other, then I know all the angles that match up, all the corresponding angles, you hear that word? Okay, they means they correspond. They means they match up with each other. They're going to be equal to each other. All right? What about, here I'm going to just grab this again. What else is going to be equal? Look, the angles are all the same, aren't they? Do you see that? I took that triangle, put it right on top of each other. So the angles are all the same. What else is all the same? What do we call that? We don't just call them a line. They're not really lines. They're line segments, aren't they? Because they start and stop. They don't keep on going. But what do I call that on a triangle? It's the side, right. That's called the side of the triangle. So tell me some things that are equal about this side right here. This is a line segment. I could call it AB. I could call it BA. And how do I, wait, just give me a sec. How do I show that side? I'll put one little mark. We call that a tick mark. Remember that? It's a tick mark. All right, Timmy, go ahead. So side AB is going to equal what? DE, right, side DE. So if AB has one tick mark, what's DE going to have? One tick mark. Everybody see that? What other sides are going to equal each other? Let's do this bottom one. We'll give that 2 tick marks. Is that all right? So AC is going to also equal what? DF. Good. And then BC, we'll give that 3 tick marks. BC is going to equal what? EF. Okay? You with me on that? Now that's only true if the triangles are what to each other? Congruent to each other. So I could call this any of these names right here, couldn't I? Let's just make it easy on us. What do you think you would call it? ABC? I could have picked any of these. It doesn't matter, okay? But if I picked ABC for this one, watch over here. I'm going to say it's congruent to triangle. Now, could I pick any of these 3 letters? No. If I go in the order ABC, 1 tick mark or 1 arc, 2 arcs, 3 arcs, I'm going to have to put them in the right order over here. So I'm not going to call this FED. Okay, what will I have to call this triangle right here? DEF. All right? Not just because it's in alphabetical order, but because the A and the D match up. You watching? See the A and the D are in the first spot, and then the B and the E are in the second spot. See it? And the C and the F are in the third spot. All right? The A and the D have 1 arc, the B and the E have 2 arcs, the C and the F have 3 arcs, all right? And so they're the ones that are equal, or congruent to each other. So you do not want to do this. You don't want to say triangle ABC is congruent to triangle, let's say EFD. You don't want to say that. Why? Because just looking at this, if they were congruent to each other, that means that the A and the E would equal each other. Does the A and the E equal each other on this? No, they don't, all right? Does the B and the F equal each other? No, all right? So you're not, well, I'll just put a big old X through that. Don't do it like that. What's another way? Look, I got 6 different ways I could have named this first triangle. Let's pick one of the other ones. Let's not start with the A, though. Pick another one. You got 4 to choose from. What is it? BCA, all right. We'll call that BCA. Now watch very carefully. If I call this BCA, I'm going from 2 arcs, 3 arcs, 1 arc, right? So 2, 3, 1. Which one's over here goes in that order, 2, 3, 1? The E, the F, and the D. So I would call it triangle EFD. See, these have to match up. The B and the E have to match up. Right? The A and the D have to match up, and the C and the F have to match up. Do they match up here? Yes, they do. So there's 6 different ways that I could write those triangles being congruent to each other. I don't need to write all 6 of them every time. I just pick one of them. But you got to make sure, listen to the words, that the corresponding angles are equal to each other. All right? That angle A and angle D, they're the ones that match up, right? So those are the ones that are going to go, watch, the A is third, the D is third. The B and the E are equal to each other. The B is first, the E is first. And the C and the F are equal to each other, so the C is second and the F is second. See how they match up? All right? That's important when you write out congruent triangles. So I should just be able to look at this and know what angles are equal. I also should be able to know what sides are equal to each other just by looking at this. Look, I can combine a couple of the sides, like AB. See that right there? So forget the triangles. Forget looking at the triangles. All right? Just look at this thing right here. AB would equal what over here? DE. Good. Everybody see that? All right. What about BC? What would BC be equal to over here? EF. You got it? So I don't even have to look at the triangles. I can just look at this. They call this a congruent statement. I could look at the congruent statement and see which sides are equal to each other and which angles are equal to each other. What's my other side? I did AB and BC, AC, right? Or CA, doesn't matter. AC, CA would equal what? DF. Does AC equal DF? Yes, it does when you look at the picture. Okay? It's super important. This congruent statement is really, really important. They do some other thing. I think I'm going to skip that. Let's jump to similar triangles. What's the difference between being similar and being congruent? I'll use an example, and I'll pick the Suttons. They're not identical. You're not identical, right? Okay, they're not identical, but they look similar. Wouldn't you agree that they look like they're brothers? Yeah, I would say that they look like brothers, okay? But they're not identical twins. Identical would mean congruent, right? And then similar would mean fraternal, which they are, right? You're fraternal twins. I guess there's only two types, so that would be it. All right, you see the difference? It's not exactly the same with the geometry, but that's the way you could look at it. All right, so let's take a look at. Let's put that triangle on here again, and now I'm going to put that triangle here. Now, right now, I just copied and pasted. So look, I can put one directly on top of the other one, and they're exactly the same. They got the same angles. Oh, I should have written that down before. Okay, if they're congruent triangles, they have equal angles and what? Equal sides. Right? It's the corresponding angles, I should say, okay? The corresponding angles are equal and the corresponding sides are equal to each other. That's not necessarily true about similar triangles. So watch what I'm going to do. I'm going to take this triangle. I'm going to hit the shift button so it doesn't, watch, if I don't hit the shift button, it'll change the shape of it. Everybody see that? All right, Control Z. If I hit the shift button and click on a corner, look, I'm trying to move it all around, but it keeps the same exact shape, doesn't it? You see that? Keeps the same exact shape. You want to make it bigger or smaller? Let's make it bigger, okay? But check this out. What about this side right here? If I call, that was my AB, right? Is it the same size as this one? It's not, okay? But watch this. Let's take this triangle. Come on. There we go. It doesn't fit exactly on here, does it? But what is the same? The angles are the same. Look at that bottom left angle. It's exactly the same, isn't it? Watch this. Look at that top angle. If I put it right here, it's exactly the same. Put that right bottom angle, it's exactly the same angle. Would you agree? So what are true? What is true about similar triangles? Good. You got it. I like that. The corresponding angles. You know the symbol for angle? Remember that? All right, so I'll write it like that. So the corresponding angles are what? Are equal to each other. But are the corresponding sides equal to each other? I mean, you can see right now that there's no way. See that left side and the left side? That one on the right, or on the one on the left, is way bigger than this one right here. Everybody see that? So the sides are not equal to each other, but the sides, the corresponding sides are, I'll put are, here's a word, proportional. You ever hear that word? Yeah, you've heard the word proportion, haven't you? Yeah. What in the world does that mean? All right, well, I'm glad you asked. I'm going to tell you. I'm going to make this just a little bit smaller. Is that all right? In fact, I'm going to make it look like, so if I clicked on this, yeah, that's about, so what would you say? Would you say that big one is about twice as big? About right there, maybe. Do you think? That looks pretty good. All right. So let's put some numbers in here. I don't know. Let's say that's, no, let's say this is 10. This is 14. And this is, which one looks bigger? Does that look bigger? 16. We'll call it, I don't know. I'm just making up numbers, okay? Let's say it's that. Everybody with me? All right. If this one is twice as big as this one, then what's this side right here? That's going to be 5, isn't it? Okay, if this is 16 and it's twice as big as this one, what's this side going to be? 8, and then this one is 7. Agreed? Okay. So we say that they're in proportion. Let me show you how mathematically you can show that they're in proportion. All right? So you know which ones correspond to each other. This is the left one, this is the bottom one, this is the right one. Everybody good? So what's the left one on the little triangle? The 5. So watch what I'm going to do. In order to show that they're proportional, we're going to compare the sides to each other. We're going to do that as a fraction. So I'm going to go 10, and I'm going to compare it to the 5. You with me? Let's do the same thing with the 16 and the 8. I'm going to go 16, and I'm going to go 8. What's the next thing I'm going to do? 14 and 7. Good. Now, what I want to do is I want to see, is there any relationship between these? Notice, I didn't put anything in between, did I? What is 10 divided by 5? It's 2. What's 16 divided by 8? It's 2. What's 14 divided by 7? It's 2. And what's true about all those? They're equal to each other. So what's true about these fractions? Whoops. They're equal, and so the sides are proportionate, okay? Or in proportion, okay? If you take the corresponding sides and compare them, meaning make a fraction out of them, all three should reduce to the same exact number, okay? They all reduced to 2 over 1, didn't they? All right? I could put that over 1 if you wanted to. All right? So what must be true about triangles that are similar to each other? Well, the corresponding angles, 2 things have to be true. The corresponding angles have to be equal to each other, but the second part, the corresponding sides are what? Proportional. Or you could say in proportion. All right? This means the same thing. And how do I know if they're in proportion? I take the corresponding sides and I set up a fraction, right? I set them up and I compare them. I compare 10 to 5, 16 to 8, 14 to 7. If those 2 things are true, what's true about those 2 triangles? They are what?
Similar.
They're similar, right? They're not congruent, they're similar. So if I wanted to, I'll just make different letters here. P, Q, R, and X, Y, Z, okay? Let's name this triangle here on the left. Let's name it. Call it what? Triangle. Let's call it PQR. Make it easy. And this one would be triangle what? Now, they got to still match up, okay? The P, this angle P right here matches up with which angle over here? The X. So the X has to go first. If P goes first, then X goes first. The next one I wrote down was Q. Which one over here matches up with the Q? The Y, and then, of course, the Z. So what do we say? We don't put an equal sign. What do we put? Just a 1 squiggle thing right there. So that means that those 2 triangles are similar to each other. And if they're similar, then the angles are equal, and the sides are in proportion. Does that make sense? Let's do one example and we'll be done. How's that sound? I'm just going to try to draw this the way it looks in the book. I don't know how successful I'll be. Actually, that's not very good. Oops, that's not what I wanted to do. There. I'm trying to make this so that's a right angle right there because they make this a right angle. Come on. There it goes. You guys watching? You got your head turned. There we go. That looks pretty close to what the book has. All right, I'm going to copy and paste it, and then I'm going to hit the Shift key. What does the Shift key do when we do stuff like this? It keeps it in proportion. Actually, we'll keep that one big. We'll make the other one smaller. We'll make this one smaller. Come on, there we go. All right. That took way too long, but that's okay. All right, there's our two triangles. They tell you in this triangle that's 90 degrees. They tell you this is 60 degrees. And they tell you this is 30 degrees. Okay? And they tell you the length of that side is 3 and the length of this side is 6. And here's what they want you to do. Oh, they tell you this is 5. They don't tell you this. And they don't tell you any of the angles. Okay? So what they want to do, they call this angle A, no, I'm sorry. Call this one A, B, and C. So this is an example right from the book. This is what they give you, okay? And they tell you that the triangles are similar. So they do tell you that these two triangles are similar to each other, all right? So what you want to do is find all three angles. That should be the easy part. But then they also want you to solve for x. That's the part that's a little bit tricky. Let's do the easier part first. So let's find all the angles. So if this angle down here at the bottom is 90 degrees, tell me something. Angle A is 90 degrees. All right, so that's one of my answers. That's what they ask for, okay? This one over here on the left is 60, so what's 60 over here? Angle B. Remember, all the angles are exactly the same, right? And then, of course, what would this be? 30. So that was easy. Would you agree? Yeah, super easy. Now, here's the problem. It's finding what x is equal to. Now, is this exactly double this? It's not. That's 5 and that's 3. All right? But it's still in proportion. So watch what I do. I'm going to take the two that I know. I know the left side is 3 and this left side is 5. I'm going to make a fraction out of it. Everybody watching? Yeah. So I'm going to go 3 over 5. It's kind of what we did earlier, right, with the 10 over 5 thing. Mm-hmm. All right, but this is 3 to 5. For every 3 this way, you go 5 this way. And we're going to set it equal to, look at the other two sides. You got a 6 and an x. Well, no, it's not over 10. 6 over what? Well, the answer is, okay, but that's not where we're going to set it up, okay? So we're going to go 6 over what? X, because we don't know what it is. You with me? Mm-hmm. Now, if you knew this side right here, you could put this one over this one, but we don't know either one of them, so you can't really do anything with that, all right? So what are we going to do here? We're going to solve for x. Well, what math is involved to solve for x here? This is where you use cross multiplying. Do you remember doing cross multiplication? Probably did that in middle school sometime, all right? 6th grade probably. You did cross multiply. What does that mean? It means when you have a fraction set equal to a fraction, we can always multiply diagonally. So what is 3 times x? 3x. And then what am I going to multiply? Those two. It's 5 times 6, which is 30. Everybody see that? You remember doing that, don't you? Cross multiply? Yeah. And now just divide by 3, right? And that cancels. X is what? 10, just like you said it would be. All right? So that would be a 10. Come up here if you wanted to and say x is equal to 10. Make sense?
So then we just don't have to find the other.
Yeah, you can't. You really can't. I mean, you can. Actually, we've done it. We've done Pythagorean theorem. If you wanted to,
It's a right angle.
you could actually find it because that's a right angle. Yeah. That's 3 and that's 6. You could actually find that. We got time. Let's do it. That's fun, right? So how would I do this? Now, I don't know this, right? We'll call it b. We'll call it b. So I go what? 3 squared plus b squared equals what? 6 squared. Now, this may not come out really pretty, but it's all right. We can still get it if we wanted to. 3 squared is 9 plus b squared equals 36. Okay? And then subtract 9 from both sides, correct? That cancels. So b squared equals, what's that? 27? Is that right? Yeah. 27 and 9 is 36. Yep, it's 27. Now, what do we do to get b by itself? Square root. Okay, so b is equal to the square root of 27. Now, they're not going to ask you to do this. We're just doing this on our own just because it's kind of fun, all right? So b is the square root of 27. Now, we'll call that y. What if I wanted to find that? Well, I already know 3 and 5 go together, don't I? So 3, I'm comparing 3 to 5. What am I comparing here? Square root of 27 to what? To y. And now we solve by cross multiplying. So we cross multiply, we get 3y equals what? We'll put the 5 first. 5 times the square root of 27, right? We could simplify that. I'll show you. I'll show you the whole thing, okay? Now, they don't ask you to do this, so don't get all worried about it, all right? The only thing they're going to ask you to do is find something like that, all right? But this is just for fun, all right? So divide by 3, divide by 3, so y equals. Now, it looks like you can't do anything with that, but you kind of can. The square root of 27. I'm going to blow some of you guys away here. The square root of 27. What times what? 9 times 3. So watch what I do. So would you agree that that's the same thing as that? Yeah. We have a rule in algebra that says if you have two things being multiplied under one big square root, we could split them up like that. Do you remember doing anything like that? Kind of makes sense that you could, though, doesn't it? Right? Square root of 9, square root of 3. Yeah. What is the square root of 9? It's 3. Now, you can't simplify the square root of 3, so you just leave it like that. So watch this. Instead of writing square root of 27, what could we write? 5 times 3 times the square root of 3 over what? No. It's over 3. Look what can happen. This 3 cancels out with that 3. So the best way to write it is what? 5 times the square root of 3. And that's what that is. 5 square root of 3. Now, here's something else. We could have done this a lot easier if we would have remembered something from geometry. Do you remember doing 30, 60, 90 triangles in geometry? And we said that the long side is the square root of 3 times the short side. Any of that coming back to you?
I've never learned that.
Okay, well now you have. Look, I got a 30, got a 60, got a 90, okay? So watch this. Look. Everybody look up here. This is kind of cool where it all comes together here. You could have gone through all that mess, right? Or you could have looked at this and said, oh, I got a 30, 60, 90 triangle. This is my short side. How do I know it's the short side? Because it's opposite the smallest angle. So that's the short side. So what does my theorem, my little rule say? The long side, which is this one, it's opposite the 60, is the square root of 3 times the short side. So instead of going through all this mess right here on this particular triangle, I could have just said, oh, the long side is the short side times the square root of 3. There it is. So I could have just looked at it and said, oh yeah, that's 5 square root of 3, and not done any of that work, and I still got the same exact answer. That's kind of cool, isn't it? Yeah. It's neat that it works both ways, all right? They didn't really expect you to go through all that in the book. They don't go through that in the book, but again, that was fun, wasn't it? Good. All right. Are you just messing with me that it was fun, or? I think it was. I think it's kind of cool. I think it's kind of cool to see that. We learned a lot of new things today. Most of the stuff that we just did on this problem, you really wouldn't have to know, all right? Because they did not ask for this, and they did not ask for this, so I wouldn't even worry about it. It's just that 3/5 thing. That's the only thing you had to worry about on here. And that's it. So now you should be able to do, here's your assignment. I'll put it in red. I usually put it in red. It's, what was it anyway? I wrote it down, 41 to 44. Yeah. And we're going to do them all, though, okay? There's not that many. All right, it's only 5 problems. All right, we're going to do them all. Yeah, rate of pass. So we're going to call it, let me get my book. I did write it. Now, this is in the lesson plans, but it's for Wednesday instead of Thursday. So it's page 37, 41 to 44. And it's section, what is it? C, R3C. R3C, page, forgot already. What is it? 37. And you're doing 41 to 44. And you're going to do them all. All. There's not that many. There's only 5, all right? Or 4, actually. There's only 4 problems, all right? You should be able to do them all, all right? So go ahead and
Shall we start?
you can work on that. Yeah. Actually, we got to go over the homework from last night, so let's do that first. Let me close this out, and then we'll go over the homework.